Welcome back to another episode of Additional Mathematics Syllabus 4049, where we look at chapter 9 of our textbooks, which is known as Trigonometry. And today, we'll be looking at Trigo graphs part 2. So in part 2, we are going to cover two things. Hold on. One is tangent graphs. And another one is the a sin bx plus c, or a cosine plus or minus. So we're going to cover these two things. One is tangent graphs, and the second one is this general formula, a sin bx plus or minus c, or a cosine bx plus or minus c. Excuse me. Alright, so without further ado, let's go into tangent graphs. Do you mind if I erase all of this? So we're going straight into tangent graphs, yeah? So I will write in yellow. So we are going to sketch y equals to tangent x. Alright, so for tangent x, the shape is very, very different from sine and cosine x graphs. Okay? Hold on. Because I have my y-axis and my x-axis. Okay, maybe I'm gonna make it smaller. Alright, so y-axis, x-axis, your origin. Okay? So what do we know in a tangent x graph? We still know that for a graph, it ranges for your x values is 0, less than or equal to x, and x must be less than or equal to 360 degrees. That's one. And the second one will be your y value is 1 or -1. They call this the max and minimum value. Okay, I will shift this here. Okay, I'll put it over here. Okay, so this is how a tangent x graph looks like. So first we will draw three asymptotes. So just dotted lines. Let's say one here and another one right here. Actually, I will draw 4 asymptotes, not 3. Sorry. So let me increase my line. Okay, so this is my x-axis. So we know that it ranges from 0 degrees, less than x, and less than 360. So same thing, let's draw. But a tangent graph, this is actually very different, because in tangent graphs, you do not need to put this. And you just only need your x values, alright? So that's the bonus thing about tangent graphs, okay? So we know that this coordinate here is 90, this coordinate here is 180, this coordinate here is 270, and this is 360. So how does it look like, right? So from the origin, we will draw up like that. And then, because we don't draw at 90 because tangent 90 is NA or undefined. You can press in the calculator and you will know that tangent 90 is undefined. Or in your calculator, they say math error. Okay, so and the next shape will be like this. So it will cut through 180 and go up like that. Whoops, sorry about that. So it will look like this. So this is a tangent 180. So if we press so you might wonder, why do we cut at tangent 180? So if we press in the calculator tangent 180, we will actually get 0. So tangent 180 is 0, and that's why if we look closely here, the graph cuts at 0 when it's 180. So that means x is 180 and y will be 0. Okay? And you can check tangent 270. You will realize that we will not draw anything there. Why? Tangent 270 is undefined. NA or undefined. Excuse me. And in your calculator, it should say math error. Okay, and you will see that it will cut here. The shape will be like this. Alright, because if you take a look, tangent 360 is just also 0. So it will cut at 0 and the graph will still look like that. Okay, the dotted one is how it will look like, but in the exam, just draw the ones that are like in solid lines, is not in dotted lines. Yeah. Okay, so this is a one side note for tangent graphs. You do not need to write your y values, you just need your x values. Okay, and these are the reasons why we do not cut at tangent 90 and 270. All right, and you might wonder why do you only draw it like that? If we type in tangent 0 in our calculator, it will be 0, so it will look something like that. Okay, but I repeat, don't draw the dotted line. So your final answer should be like this. Okay, I'm gonna erase it. Okay, and tangent graph is very rarely tested in your O levels, in your school papers. But for O levels, they might come up. I don't know if they will set it, but so far, AMath papers I've seen rarely have tangent graph. Mostly is sine or cosine. Okay, so this is your tangent graph. I will erase this and I will take a screenshot. But before I take a screenshot, always remember to label your graph. So this is your y equals to tangent x graph. Okay, so yeah, I'll take a screenshot first. And alright, now we will draw y equals to negative tangent x graph. Okay, so I'll draw it in white. So this is your y-axis. And your x-axis. Okay. So of course we have your origin here. So same thing, negative tangent x is just the other way round. Okay, so I'll give you some tips on how to remember tangent x curve, which I'll write it down after. Yeah. Okay, so I will draw the same 4 lines. Okay. So we know our values here: 90, 180, 270, and 360. So for tangent graph, right, the curve will be like that. Okay, so we know that tangent graph is, for tangent, positive tangent x is like that, like that, and like that. Okay, so these 3 that are in yellow, this is a positive tangent x curve. Alright, but negative tangent x is just a mirror image, so it will be, hold on, let me think. If I'm not wrong, it should be like this, and I don't think I'm wrong. It will be like this. Hold on. You have to cut 180 and like this. Okay. So this is your tangent x graph, and yes. Alright. Wait, actually, yeah. Alright, so again, remember tangent 90 and tangent 270 is undefined, or NA and in your calculator it should appear as math error, but we know that tangent 180 and tangent 360 is 0. That's why it will cut at the x-axis. And if you look at tangent 360, why do we draw like that? Because our curve will be like this in dotted lines. Alright, so in the exam, only draw the solid lines, do not draw the dotted lines, okay? And if it cuts at 0, it will cut like that as well. So yeah, no need to draw the dotted lines, just draw the solid lines can already. And examiners just want to look out that you cut your graph at 180, you draw the full shape. Alright? So that's about it for tangent graphs, and just wait a minute. I will be going through with you what the a sine bx plus c is, and oops, I forgot to label my graph y equals to negative tangent x. Alright, so I'll take a screenshot of this, and yeah, we'll go into a sine bx plus c. And the a cosine actually is the plus minus. So there are two different kinds of, formulas, yeah? So this is your y equals to a sine bx plus or minus c. And I'll write, if I'm not wrong, I used red for cosine. Let me check. Yeah, actually, never mind. I remember that I used red. Okay, and y equals to, did I use red? Hold on, I know I'll just use red. Okay, a cosine bx plus or minus, sorry, I'll write it like that, but for your sake I'll write it plus or minus c, so you won't get confused. Okay, so you know that if let's say I give you an exemplar, but before I give you the exemplar, I will just tell you that y equals to a sine bx plus minus c. What does this mean? Yeah, a means your amplitude. In physics, you should know what amplitude is from the crest to the equilibrium point. Alright, and then let you know that b is your period. And what is the definition of a period? The definition of a period is the time taken to complete one oscillation. We have learned this in waves. So yeah, for physics students, this is very important. For bio students, take it as extra knowledge. Alright. And for cosine, it's the same thing lah, huh? And amplitude just means like trough to equilibrium. I'll just write equi, or crest to equilibrium. Alright, so we know for and what is c, you might wonder. Okay, c basically just means that it is the shifting of the graph. Alright, so in part 3, we'll be doing some word problems, and you will know that and you'll understand about the meaning of shifting. So if let's say, now I will give the example. I will say that if let's say y equals to, example, I'll write it in green. So if I say that y equals to 3 sine x plus 1, that means the graph will move up by 1. Okay, and you know that 3 is your amplitude, and you know that your x is invisible 1 here, so you know that your period is 1. Okay, so I will give you guys the formulas as well. Alright, so and it's actually the same thing for a cosine bx plus c, yeah? So long story short, I'll just write a quick summary over here in blue. So if we see this kind of formulas, a is normally your amplitude, which what I've defined just now, which is over here, amplitude, sorry. And we know that b is your period, whereas the time taken to complete one oscillation. Physics students, you should know what period means, yeah? It's a wave. It has been learned in waves. Alright, and C is the shifting of the graph. So now what if I change my value to -1? Alright, so if let's say I change it to, now I switch this plus to minus, that means the graph will move down by 1. Okay, I will erase the positive to create less confusion, and yeah, it's the same thing for cosine, okay? It's just that different Trigo functions. Just one is sine and one is cosine. Okay, sorry for the, yeah, you know it. Alright. So now I'm gonna give you the formulas on how do you find period. Okay, so to find period, right, there are two formulas. One is in degree and radian. So to find period, okay, there are two formulas. Once again, degree and radian. Actually, it's the same thing. It's just a conversion only. Okay, so for period, to find the period, we will take 360 degrees divided by b. Alright, and for radians is 2 pi over b. Do you remember this conversion where pi is 180 and 2 pi is just 360 degrees because it's just times 2? That's how I got my radians as 2 pi. Okay, so if let's say we use the same exemplar here, y equals to 3 sine x plus 1. What is the period? So we know that your b has an invisible 1 here, and this invisible 1 here is a b, right? Because a sine bx plus c, or it can be minus c. Really depends on the question. So period is 360 over 1, which is just 360. Alright, so we know that it ranges from 0 to 360 degrees. This is always in every graph, but the period will tell you that in one complete oscillation or one complete sine x or cosine x graph, you must have the values from 0 degrees to 360 degrees. Alright, so I'm just gonna erase and so what else? Yeah, that's it for the a sine bx plus c and the a cosine bx plus c. Basically, the a, b, and c all mean the same thing. It doesn't matter if it's sine or cosine, but yeah, it means the same thing. Alright. Okay. So long story short, it means the same thing, yeah. For the a, b, and c, once again, it's just we are using sine and cosine, so it's just two different shapes, but a, b, and c is the same throughout. Okay, so hold on, I'm just gonna remove this first, and I'll write the signs here. Plus or it can be a minus. Okay, so if I change to -1, okay, so now this is what we have for the a sine bx plus c and the a cosine bx plus c. Alright, now I'm going to tell you some fun facts about the tangent graph. Okay, so this part is going to be very interesting. Alright, so these are some fun facts about tangent graphs. So I just write a star there, not because it's important, they are just fun facts. Alright, and of course we know it's about tangent graphs. Alright, so for tangent graphs, we know that what's your amplitude? Alright, we know that the amplitude is a infinity. Alright, the maximum value is also an infinity. The minimum value is a negative infinity. And then the period is not 360, it's 180 over b, or it can be pi over b. Alright, if I were to explain it, yeah, because tangent graph don't really come out, so I didn't explain this a lot, but we can say y equals to a tangent bx. Hold on, I'll write the formula in a different color. Y equals to A tangent bx plus or minus c. Okay. So basically same thing. A is your amplitude. I'll just write ampli for short. B is your period. And C is the shifting. Okay, so it still means the same thing, yeah? Okay, so yeah, that's about it for tangent graphs, and the white one are in fun facts, and the yellow one is to give you a clearer idea on how does it work. If not, like, where did the B come from? You know what I mean? Alright, so if we know that your amplitude is infinity and your maximum is infinity and your minimum is negative infinity, why is it so? Alright, so you notice, right, if a tangent x graph, I'll just draw like that. So you notice that a tangent x graph, it will cut like that, right? You will notice that your y value will keep going down. It will never stop. It will not stop. Right? The x there just means no, it won't stop. Alright? So that's why it's infinity. And for your maximum value, it's also infinity, because if we end at 360 over here, it will still go up like that. It also won't stop. That's why it's infinity. Alright, I'm going to explain it again. So if I draw a proper one to show you. So I'm just going to draw, you know what? I'm just going to draw the whole thing. Okay, so 90. This is just a sketch, but don't draw like that. Okay, so we know that it's like that, right? So if we notice, right, this is how it will look like if we didn't complete it. But in the exam, this like that, and the 180. So in exams, right, the solid lines that I've drawn, they are already good enough. Okay, no need to draw the dotted lines. Okay, it's already good enough. Very, very good already. Okay, so you'll notice that the dotted lines, it will keep on going down. So you see it will go down all the way like that. It doesn't stop at some point, and it won't like even turn at some point. It will only turn when it is at the origin, right? If you see, if I were to draw like that, right? So you see, I draw again, I draw like that. See, I draw. It only turn and cut at the origin, right? Follow the movement, yeah? Look at this. Okay, I'll draw in purple, yeah? Follow the movement, see? Do you see that it only turns at the origin? That's why it is infinity and negative infinity for the minimum and maximum. Alright, so just now what I explained for this part here is the minimum. I will explain the maximum. Why is it infinity? Because if we go up, continue to go up like that. Okay? So, follow the movements. You see that it also doesn't stop. Same as the minimum. But this time, because maximum is above the origin, that's why it's positive infinity, not negative. Alright? So that's about it for tangent graphs and the A sine bx plus or minus c, or the A cosine bx plus or minus c, and the A tangent bx plus or minus c. And yeah, I guess it's gonna be 24 minutes soon, and I'll end it off here. So in the next video, which is Trigo graphs part 3, we'll be looking at about 2 to 3 or 4 word problems. Alright, so be prepared that it's gonna be a bit long. And yeah, if you just need a break anytime, pause the video for the next part 3, and just go take a break if you need at any point of time. And I just hope that you guys are learning, right? Alright, so I'll see you in part 3. Bye.